I'm going to try and go through this quickly. We've got the electrical currents review sheets here. So we're going to start at the top left. It says draw parallel circuits with 3 bulbs, where 2 bulbs are turned on or off together, and the third one is independent from them. You can see here, so I've got my power source. So it's a parallel circuit, but I've put, because it wants 2 to be turned on or off, so I put 2 bulbs parallel to each other in like a separate parallel circuit there, and then made a bigger parallel circuit for the other one. So there's my switch to turn those 2 independent. If this switch is off, then current can still run, if this switch is on, to this light and come back again. And obviously if this switch is switched off and this switch is switched on, the current can hit these 2 and come back around. Draw a table that shows the relationship between series and parallel circuit and voltage and current. So this is the table we try and do, SCS, if we're getting stuck remembering which one is which. For example, is current the same in a series or a parallel? Well, you can remember SCS, just like that furniture and carpet shop. In a series circuit, S, the current, C, is the same. And once we know that current is the same in a series circuit, then current in a parallel circuit must split up and add up at the end to the supply current. Same with the voltage. If current is the same in a series, then voltage must add up in a series. Therefore, voltage must be the same. So it's like that crisscross effect. So if I get a pen, so that crisscross effect there. Okay, let's go to this one now. So draw a testing circuit to find the resistance of a device. So this is your standard test circuit. You've got your ammeter in series. You've got your component. Sometimes that's a bulb. Sometimes it's a resistor. Sometimes it could just be a fixed wire. You're going to put your voltmeter across that, because voltmeter can't go in series. You've got your variable resistor. These could be anywhere, mind. This thing could be over there, and the ammeter could be over there. And you've got just a power source there. And then usually, for a 6-mark question, it will ask you how you use this circuit to get a series of readings for current and for voltage. And you would just adjust this variable resistor. You'd set it to the maximum setting. So the maximum, when you've got maximum resistance, you've got little voltage and current going through the circuit. And then you would just gradually decrease this. So it allows more voltage, and you would usually use your voltage as your independent variable. Well, that means I'm choosing my values for voltage. So it would be, say, I'd move this until I got 0.5 volts, and then I'd measure that current, and then I'd move this until I got 1 volt, and then I'd measure the current, and then I'd move this until I got 1.5 volts, and then I'd measure the current, and then we'll have a look at some graphs of what usually happens depending on the component you use. Because we got to know about 3 components. We've got to know about a fixed resistor, we've got to know about a lamp, and we've got to know about a diode. Anyway, I'm going to finish this box off. Give the voltage values for this circuit. So here's your total. This is your total voltage. This is your supply voltage, 6 volt. So you got 2 3-volt cells there. And then you can see that this is a parallel circuit, because even though it doesn't look like the ones we've been doing, you've just got to follow these. It's sort of like a maze that if you can get the current through, and it comes back, then you know there's going to be a connection there. Sometimes, if I just show you quickly, and then I can undo it, when we draw a parallel circuit, we would draw it like that. I know that's a bit messy, but that's essentially the same thing. It's just this one looks a bit different, so I'll undo that a minute. Let's get rid of that. I've lost my train of thought now. So that's why. So voltage is the same in a parallel circuit. So across this branch, there's going to be 6 volts. So if we measure that, there's going to be 6 volts running through that lamp. But there's going to be 6 volts running through this as well. But these two are actually in series. So if it's in series, we know that they add up. So there's going to be a 3 across here, and there's going to be 3 across there. Even though there's 6 coming through, there's going to split that voltage between the two. And then it's going to add up again and come back to be 6 here. So it's going to be 3 there, 6 there, 3, and 3. Let's go up to these now. So we was talking about the standard test circuit there. If you use a filament lamp or a bulb, okay, it's the same thing, you will see that if you measure voltage against current, that it's going to start, so the more voltage you get, so as we increase this voltage, you're going to get a lot of current at first to make that lamp quite bright. But then as that lamp starts to get brighter and brighter, it's going to heat up. And with that heat is going to increase the resistance. So it's going to start to tail off here. So you can see as we start, even though we're increasing the voltage, this current is not going up anymore. It's kind of just trailing off. So that's why it looks like that. It's like a curve. And I always like to think, for filament lamp, you could turn this into an F. And that looks like a filament lamp there. So if you're asked to recognize these, then that's the easy way. But it's nice to know what's going on as well. For the fixed resistor, it's just going to be one straight line. It's directly proportional. What that means is if you, and I don't know why I've got, let's get a thinner one. If you've got something that's directly proportional, as you sort of double this one, you'll get the same. So you'll double this. If you triple this, you'll triple that. And even though there might be different values here, it's directly proportional. So let's just say I've got a value of 1 here, and I've got a value of 0.5 here. If I double it and I got a value of 2 here, then I'm going to get a value of 1 here. And the gradient of this line depends on whether you've got a good conductor, really. If you've got something like copper, you're going to get a nice steep line like this. You're going to get it going up there. And if you've got a nichrome wire, which is a mixture of nickel and chrome, it doesn't conduct electricity very well. It's going to be less current coming through for that voltage. So as the voltage increases, you're going to get less current. So it's going to be a less steep line there. And then we've got the diode. Well, I've got the diode. Again, you can easily recognize it because you could say, well, that looks like a letter D now, doesn't it, if I put a D on there? I think, anyway. But, again, better to understand it. Let me undo that again. So let's look at it. What's going to happen is, and we're better off looking at this one here. You're going to get, as you increase the voltage, you're going to get no current until you come to a point, and then it kicks in. And then you get a really dramatic increase of current then for voltage. Look, I'm only increasing the voltage a tiny little bit from this step to this step, and you're getting a lot of current through. A lot of current there. I've done the axes different here. I've gone into the negative axes. This is because sometimes when you come to this standard test circuit, and I know we haven't talked about the flow of electrons much, but usually there's going to be a direction for this flow of electrons. And if I switch this battery around, if I use the little end there and the big end there, so on each battery you get a positive and a negative end. If I switch that around, then this diode, if I use a diode, is only going to allow electricity or current to flow in one direction. That's the whole point of a diode. You see them all over the shop in computers, and it's to really turn that AC, alternating current, into direct current. And whereas these graphs, you will see them, you will see these sort of come down like that, and you'll see this filament lamp, you'll see the shape like this, okay, in the negative. You won't see that in a diode. And maybe I'll do maybe I'll do a separate video on this, again, because it's important, because it might come up in your... Well, it's probably going to come up as a 6 marker in your exam paper. And then it says, what does the term directly proportional mean? Well, as we looked at this, it says if one variable doubles, then the other is going to double. That's probably the easiest way to explain directly proportional. This box here says, explain what happens to the values of resistance and current when resistors are connected in parallel. Well, I've done a little diagram there, and then I've said that they're going to decrease. The total value there is going to decrease, and we can, well, the next question there is calculate the total resistance of putting 3 of these 6 ohms in parallel. And we've got to use this equation. 1 over RT equals 1 over R1, and so on, depending on how many resistors we got. So in this case, it's just 1 over 6 plus 1 over 6 plus 1 over 6 gives me 0.5. And then, that's not the answer, because 1 over RT equals 0.5. So now RT, I've got to put 1 over 0.5 now to get my answer, which is 2 ohms. And you can see 2 ohms is less resistance than the 3 6 ohms ones. So it's actually decreased. If a device has a power rating of 300 watts, so what have I got here? I've got power, because it's watts, and used for 45 minutes, so I'm looking for time. I'm looking at time here. How many joules of energy will it transfer? So I've just used that equation, E equals PT. You can stick it in a triangle if you want, but it's already arranged for us here. And I've just got to convert that 45 minutes to seconds, and that's easy, because literally if a second's worth a minute is worth 60 seconds, so I got 45 of those 60 seconds, so that's just 45 times 60, and that's my answer. It comes out to be 810,000 joules, or you can say 810 kilojoules. And if you look at the prefixes in the front of your exam, that'll be easy to do, although they'll accept this answer, but we'll have a separate lesson on converting back and forth with kilos. It's a 12-minute video now, so I'm just going to do the rest of this video in another one, because I just like to talk.